We're going to discuss now how to work with a matrix in R, how to construct matrices, and how to carry on some basic operations for matrices. As you may remember, a matrix is a two-dimensional array of numbers. And we can manipulate matrices by reading data from a file for which we may use the built-in function read table, but we can also create a matrix entering numbers by hand. We would need to specify a vector that contains the entries of the matrix, and then we would reshape this vector into the desired number of rows and desired number of columns. For this, we will use the built-in function matrix. So for example, let's say we have a matrix. We're going to call this matrix y, capital Y equals matrix. And in this command, we have to specify first the vector that contains the entries we want to store into a two-dimensional array, followed by the number of rows. I'm going to say I want to create this with 2 rows and the number of columns. So here we're creating a matrix that has 2 rows and 3 columns. And I'm going to say that the numbers we're going to set in there are 1, 2, 3, 4, 5, and 6. Okay, so I'm going to hit enter. And now I'm going to display what we just created. So the numbers stored in this variable y are 1, 2, 3, 4, 5, and 6. You may observe that these numbers follow a pattern in which they are stored by column, right? So the first column contains number 1 and 2, second column contains 3 and 4, third column contains 5 and 6. In other words, by specifying the values in this vector, automatically this command matrix sort these values column-wise. That is the default action. If we instead would like for these values to be stored per row, on the first row and then second row, we can do that by specifying, by making use of a command, a parameter that is the parameter by row. For example, we can say here by row equal t meaning true. Okay, and now we can see how the values are stored by row. So 1, 2, and 3 are in the first row, 4, 5, and 6 are in the second row. Let's illustrate this with another example. Let's say we have a matrix, say a matrix that we call A, and here we're going to store the numbers from 1 through 9. We want 3 rows, and we want these numbers to be stored by row. I'm going to type a semicolon and then type the name of that variable, and this will display the output here, and we can see how these numbers from 1 through 9 are stored in this matrix by row. We could also create a matrix that contains the same constant value. For example, let's say we want to create a matrix of ones. So we can type something like this. We know the first entry is always the vector containing the entries we want to store, and the following input argument is the number of rows, and the next one is the number of columns. So let's say we want to create a matrix with 50 rows, 50 columns, and if I write here the number 1 on its own, this will create a matrix that contains the number 1 across its. It's a little tricky to visualize here. Maybe I stretch this console, stretch this a little farther. Okay, so maybe let me do this for effect of visualization is construct a 10 by 10 matrix with all ones. Okay, so we can do that by using the command matrix. Also, to construct when constructing matrices, we may use vectors that have the same number of entries. So if they match, the vectors match in size, we can basically put them together or bind them together. In fact, we can bind vectors of equal size. We can also combine vectors with matrices, and we can glue together matrices. We can use this command called cbind. So cbind is a command that is going to glue basically two objects, two vectors of matching size. So let's say that we want to put together the vector with numbers 1, 2, and 3 together with the vector 4, 5, and 6. And together with the vector 7, 8, and 9. I'm going to say that this now is called, I'm going to call this A. Okay, type here semicolon, and this will be, you can see how these numbers are stored on the columns of this matrix precisely because we are specifying with this command cbind that we are basically pasting or gluing the columns next to each other. We could also do a similar thing if instead of cbind we bind or paste together the rows. Okay, then if we put together the rows, then this is what the matrix would look like. You can see now how 1, 2, and 3 is stored on the first row, while before, when we were using cbind, 1, 2, and 3 was stored in the first column. Another important thing about working with matrices is to be able to address or access some of the entries of the matrices. And since a matrix is a two-dimensional array, when we want to access an entry of a matrix, basically we need two coordinates. We need information about the row number and about the column number. So, for example, here's the matrix A, and if we wanted to access the entry on the second row and the third column, we would say A square bracket 2, 3. This is specifying that the row number is 2, the column number is 3. So the row number is 2 and the column number is 3. That means we are referring to the number 8, and the number 8 is stored on row 2, column 3. Okay, so for addressing or accessing entries in a matrix, we need to use the square brackets. If we type something like this, 2, on the first entry of the square bracket, we'll be referring to information that has to do with the rows. And in this case, we're referring to the second row of A. Following after the comma, we will be referring to the column numbers. So here we're referring to columns 2 and 3. So if you look at the second column of A and columns 2 and 3, so this is accessing a subset of the matrix, which is the vector that contains entries 5 and 8. Similarly, we could define a submatrix of a given matrix. For example, let's say that C is entries in A that contain rows 2 and 3 and columns 1 and 2. right? So we're looking at A, rows 2 and 3, but we're only interested on the first and second column. So that gives us this submatrix with entries 2, 5 on the first row, 3 and 6 on the second row. We can also do replacements, okay? So, and maybe this is a good time to point this. If we were meaning to address an entire column or an entire row, we could do that by simply leaving that space blank. So if we type A square brackets 1 comma blank, that means row 1 and all the entries. Okay, and if instead we say blank comma 1, that means all rows column 1. Okay, this is a way of accessing an entire row or an entire column. Let's say, for example, that here we have the matrix A, and we do a replacement or a substitution. So we substitute the first column, the first row, with some other numbers. Here I'm going to use a built-in number. This is a random number generator, R out of random and unif of uniform, and we say 3 here, and this will substitute some of the entries. This will substitute the entries on the first row with numbers that were sampled from a normal, from a uniform distribution. Another important thing with matrices is to carry out operations of matrices. So things like, let's say we create a matrix A, and let's say that A contains numbers 1, 4, 9, and 16, and that these numbers are stored in 2 rows and 2 columns. So this is the matrix A. Then let's now take the square root of these entries. So we can do square SQRT of A. And you can notice here how square root is a built-in function, and by specifying that built-in function and passing the matrix as the argument, that operation is performed element by element on the matrix. So it's taking the square root of 1, it's taking the square root of 9, square root of 1 is 1, square root of 9 is 3, square root of 4 on the entry 2, 1 is 2, and the square root of 16 is 4. So by default, the standard operations are operations that take action in every element of the matrix, right? So we could say define another matrix B. I'm going to say this is 1, 2, 2. So here's the matrix B. A and B have the same number of elements. They match in number of rows and number of columns. So we can do things like A plus B, A minus B. All these operations are carried out on every element. A divided by B. So here's where we need to be careful. With an operation like A divided by B, that means that every element, the 1, 1 element of A is divided by the 1, 1 element of B, and so on. One has to be careful when intending to multiply a matrix. Matrix multiplication is an operation that we can do by using the multiplication operator with specific syntax. So, for example, let's say we define a vector V with numbers 1 and 2, and we want to multiply A times V. Okay, so we would have to type something like percentage times percentage V. if we just type A times V, then this gives us something that probably is unexpected for most of us. The multiplication operator without the percentage signs is another operation here. It's basically an operation that is not the standard defined matrix vector multiplication. Similarly, if we want to multiply A times V in terms of the matrix multiplication, we will need percentage sign times B. This would give us a 2 by 2 matrix as expected. This concludes the introduction to matrices in R.